Today you already read
Yes.
basal nuclei, limbic system, lateral ventricle, white matter, meninges, and blood supply.
Finish. Okay, एक chapter next class.
And circulation of cerebrospinal fluid. Only our next classes will nervous pathways. Now from page
239.
39,
346.
46.
Okay.
CO.
Give me copybook or piece of paper.
हेलो फटाफट यहाँ अलग से
Okay, if we cut brain horizontally, this is thalamus, this is caudate nucleus. What is it?
इंसुला
Insula. Okay. If we cut here, we will see head, that is head of caudate nucleus, only head. Because caudate nucleus consists of head, body, and tail. Here only head. This is thalamus, that is thalamus. Laterally, if we cut here, this is lateral side, that is cortex of insula, clear? And we will see the same. This is nucleus lentiformis, and this another nucleus is claustrum. Yes, good. And three basal nuclei you need to know. First, that is corpus striatum. Corpus striatum, it include caudate and lentiform nucleus. Between them, we can see internal capsula interna, that is white matter which has projectional fibers. And caudate and lentiform nucleus together, that is first basal nucleus, corpus striatum. Why it is one nucleus? Because if we continue to cut brain in ventral part, caudate nucleus, they join together with lentiform nucleus, and it will one gray matter in ventral part. In dorsal part, between them present white matter. That is why in dorsal part we speak about caudate and lentiform nucleus, but together they forms corpus striatum, first basal nucleus. Second basal nucleus, that is claustrum, gray matter between nucleus lentiformis and cortex of insula. And last, it is impossible to show in one level, that is why here it is absent. But if we cut temporal lobe, in lower part of temporal lobe here, inside of temporal lobe, we found another nucleus, that is amygdaloid body. That is three basal nucleus, corpus striatum, claustrum, and amygdaloid body. And I already said that corpus striatum consists of caudate and lentiform nucleus. Caudate nucleus has head, body, and tail, and lentiform nucleus subdivides into three parts with the help of white matter, and peripheral part of nucleus lentiformis, it has name putamen, and two middle parts, this is globus pallidus. Here it is globus pallidus lateralis and globus pallidus medialis. In general, that is globus pallidus and putamen. In physiology, we speak about striopallidar system. In anatomy, corpus striatum. In physiology, striopallidar system. In this case, strio, that is caudate nucleus and putamen, and pallidum, that is another part. Striatum and pallidum, that is striopallidar system. In physiology, this striopallidar system, that is part of extrapyramidal system. Today you know that we have pyramidal tracts or pyramidal system. It starts from gyrus centralis and lobulus paracentralis. They are tractus cortica spinalis and cortica nuclearis. And striopallidar extrapyramidal system, they are all another descending tracts. Rubra spinalis, tecta spinalis, no, not spinalis, from brain to spinal cord. Rubra spinalis, tecta spinalis, vestibula spinalis, oliva spinalis, and reticula spinalis. And this striopallidar system, it is also part of extrapyramidal. Next time I will draw a diagram of extrapyramidal system, and we will speak one again about this striopallidar system. Clear? Well, now white matter. White matter consists of three types of fibers: associative fibers in one hemisphere. Between right and left hemisphere, we have commissural fibers. They join right and left commissura. And projectional fibers, they join together hemisphere with lower parts of brain and with the spinal cord. Associative fibers, you can see in this model. Look here. Associative fibers we subdivide into short and long. Short fibers between nearest gyri. They are fibra arcuata cerebri. Fibra arcuata cerebri between nearest gyri. And long associative fibers, for example, from frontal lobe continues to parietal and finish in occipital. This is fasciculus longitudinalis superior. Between temporal lobe and occipital, we have fasciculus longitudinalis inferior. Between frontal, parietal, and temporal, fasciculus uncinatus. And inside of, who remember what is this gyrus?
Gyrus singuli.
He is gyrus singuli, then
Isthmus.
Gyrus paracampalis and uncus together. Gyrus fornicatus. And you can see that inside of gyrus fornicatus we have cingulum, that is white matter inside of gyrus fornicatus, cingulum. It is also long associative fibers. Now, commissural fibers. Commissural fibers, they are joined together opposite hemisphere, and largest commissura, that is what? Corpus callosum. Corpus callosum consists of some parts. This is genome, corporis callosi. From genome, this is rostrum, corporis callosi. It is trunk or body, truncus corporis callosi, and posteriorly splenium corporis callosi. This corpus callosum, it's joined the same structures in opposite hemisphere. For example, gyrus precentralis in this hemisphere through corpus callosum joined with gyrus precentralis in opposite. Post-central with post-central gyrus. Superior temporal lobule with superior. Inferior temporal with inferior. Clear? The same. Superior frontal with superior. Middle frontal with middle. All structures in right and left hemisphere joined together through corpus callosum. That is main commissural fibers in brain. Another commissura, you already know, we speak about this commissura when we discuss third ventricle, anterior wall, commissura cerebri anterior. This commissura joined together olfactory lobes. That is bulbus, tractus,
triangle, anti-epiphyseal substance.
And last commissura, that is, look here, this is fornix. You already know that fornix anteriorly continues into what? Columna fornicis, and columna fornicis finish in mammillary body. Yes. And posteriorly Yes, crurofornices, posteriorly crurofornices. Look here, this is crurofornices which goes to hypocamp and makes fimbria hypocampi on the medial wall of hypocamp. And now, both right fornix and left, both fornix join together here this is body of fornix. A body of right and left fornix join together with the help of commissura fornices. Commissura fornices. This commissura join together with the help of this commissura, right and left hypocamp join together.
Okay.
They are commissural fibers, and last, they are projectional fibers. All projectional fibers passes through internal capsule, and it has anterior horn, posterior horn, or more better, cruise, anterior cruise, posterior cruise, and knee of internal capsule, genu capsula interna. Anterior cruise has two tracts. First is tractus corticothalamicus, from brain cortex goes to thalamus. In new classification, it is absent in your textbook, that is anterior thalamic radiation, radiatio thalami anterior. But you can answer like in your textbook, tractus corticothalamicus. Number 2, if you remember in midbrain, what is most
Pontis.
pontinus. Number 2, that is tractus frontopontinus. Next is number 3 here. Corticospinalis is here. Nuclearis. Number 3, tractus corticonuclearis. Number 4, corticospinalis. Next, this fifth tract, that is tractus thalamocorticalis. From thalamus goes to brain cortex. In new classification, that is central radiation of thalamus, but you will answer tractus thalamocorticalis. Number 6, here it is, we have, if you remember, farita accipita pontinus. Here it is fibers from occipital lobe goes to thalamus, from temporal and from parietal also. And last two tracks, number 7 and 8, this is central optic tract, and here it is central acoustic. Number 7, radiatio optica, and number 8, radiatio acoustica. This is auditory tract, and this is visual tract. Optic, visual, yes, radiatio optica and radiatio acoustica. This is auditory center. They are projectional fibers. Some of them ascending, goes to brain cortex, another descending. From brain cortex goes to pons or spinal cord or, yes. What else in this diagram? I put here number 9, head of caudate nucleus, number 10, thalamus, number 11, whole this structure. This is nucleus lentiformis, and it consists of putamen, and number 13, globus pallidus, medial and lateral. White matter between putamen and claustrum, I put here number 14, that is external capsule, it was internal, this is external. And laterally from claustrum, between claustrum and cortex of insula, this is most external capsule. In Latin it is capsula extrema. And 16, that is cortex of insula. That is basal ganglions and internal capsule in this diagram. Well, next, lateral ventricle. Lateral ventricle. Lateral ventricle, that is cavitas in hemisphere. We have two hemispheres, that is why two lateral ventricles. Which of them is first and which is second? What do you think? Where first and where second ventricle? First in left hemisphere and second in right hemisphere. And each lateral ventricle consists of 3 horns: in frontal lobe, anterior horn; in occipital lobe, posterior horn; in temporal lobe, inferior horn; and in parietal part, in lobe, we have central part. 3 horns: anterior, posterior, inferior, and central part. Each horn and central part, you need to know walls of these horns. For example, anterior horn, medial wall, that is transparent septum, septum pellucidum, and lateral wall, that is head of what? Head of caudate nucleus. It is lateral wall, and superior wall, that is corpus callosum. Now, central part. Inferiorly, it is dorsal surface of thalamus, and the same inferiorly and laterally, that is body of caudate nucleus, and superiorly one again, that is corpus callosum. Posterior horn in occipital lobe. Medial wall of this horn has eminence from sulcus calcarinus. This sulcus on external surface, it press to posterior horn and makes it is yes this is it has name calcar avis, that is on the medial wall of posterior horn. Superiorly, fibers of corpus callosum, these fibers of corpus callosum, posteriorly makes tapetum, that is like cover of superior wall of posterior horn. And last, inferior horn, anterior and medial wall, anteriorly and superiorly, that is tail of caudate nucleus, medially, that is hypocamp, and inferiorly this eminence, that is eminentia collateralis, because on external surface sulcus collateralis, then it continues into sulcus renalis, and this eminence has name eminentia collateralis. And cerebrospinal fluid from lateral ventricle goes to what? No, it produced with the help of telecharaid. The telecharaid is the same present in lateral ventricle, and from lateral ventricle, cerebrospinal fluid goes to third ventricle through what? No,
Cerebral aqueduct.
No, anterior wall of the third ventricle has
Ventricularis foramen.
Yes, we have connection between third and lateral. We have 2 interventricular foramen. One is here and another here, because 2 lateral ventricles. Interventricular foramen comes to third ventricle. From third ventricle, CSF goes through cerebral aqueduct into fourth ventricle. One way from fourth ventricle, it can go to
Spinal cord.
in central canal, but central canal is blind. There is no enter from central canal. That is why cerebrospinal fluid goes back to the fourth ventricle, and it leaves fourth ventricle through what?
Rhomboid fossa.
No, in roof of the fourth ventricle, we have 3 openings.
Yes.
One of them,
2 lateral and
one median, yes. Apertura mediana, ventriculi quarti, and apertura lateralis, ventriculi quarti. And through these 3 openings, CSF goes to what? Subarachnoid space. Subarachnoid space. Some words. If you remember, in spinal cord, this is vertebral canal. Here it is spinal cord, and here is pia mater. Then here it is dura mater, and below of dura mater, here it is arachnoidea. Yes, arachnoidea. Who remember what is the name of space between vertebral canal and dura mater? Epidural space. And what is in this space?
The fiber, choroid plex, venous plexus,
Venous
Plexus and fat.
And fat in epidural space. Now, in skull, this is roof of the skull, for example, parietal bones. This is dura mater and look here. There is no space between dura mater and bone. They fuse together without space. There is no space here. That is why epidural space in skull is absent. In vertebral column, we have epidural with fat and venous plexus. Here it is, there is no space, but in some places between dura mater and bones, we have sinuses. Yes, and in these sinuses, what present? Venous blood. Yes?
Yes.
And these two layers, the same, fuse together, but inferiorly the same. We have space. This is superior sagittal sinus.
Inferior sagittal
Sinus. Look here. And what is the name of this structure, which is
that connects.
which is no? This dura mater makes phalanx cerebri. It's between right and left hemispheres. Look here. This is that is roof of the skull, parietal bones. That is dura mater, and you can see here it is broken. But this is phalanx cerebri, and this sinus between dura mater and parietal bone, that is superior sagittal sinus. And inferior border of phalanx cerebri here inferior sagittal sinus. Who remember what is this part of dura mater? This is tentorium cerebelli, because below of this structure here we have cerebellum. That is why this sinus between phalanx cerebri and tentorium cerebelli, this is, what is this sinus?
Rectus?
Yes, sinus rectus,
rectus.
stretch sinus, sinus rectus, and that is inferior sagittal sinus. Blood from inferior sagittal sinus continues into sinus rectus, and sinus rectus opens into this place. What is it?
Protuberancia.
Listen to me. You're right. In bone, that is protuberantia septalis interna. But between this protuberantia and dura mater, we have confluence sinus. And blood from sinus rectus comes to this confluence, and superior sagittal sinus, the same, opens into confluence. From confluence, then blood goes to which sinus? Who remember? Transverse sinus. From transverse, it continues into
Occipital.
Sigmoid sinus, and sigmoid sinus opens into jugular foramen. And this is beginning of internal jugular vein. Yes. Another way from confluence. This is occipital sinus. Occipital subdivides into two marginal, sinus marginalis, marginal sinus, left and right marginal sinus, and marginal is the same, opens into jugular vein. Who remember what is this sinus along of lesser veins of sphenoid bone? Sinus
Sphenopalatine.
almost. Parietal, sphenoparietal, sinus sphenoparietal. This is parietal bone. You said palatinus.
Is foramen sphenopalatine.
Now it is not here.
Yeah.
Sinus sphenoparietal. Sphenoparietal sinus. This sinus continues into which sinus? Laterally from sclera towards
Sinus
Cavernosus.
We forgot.
But you're right, that internal carotid artery, it passes through this sinus. But name of sinus is cavernosus, sinus cavernosus. And here the same sinus cavernosus. In front here, between right and left cavernous sinus, we have intercavernous, anterior and posterior. And from cavernous sinus, blood continues one way through inferior what? This is inferior. Inferior which sinus? What is this? Inferior petrosal sinus, sinus petrosus inferior, directly into jugular foramen, or from cavernous sinus another way, that is superior petrosal sinus, then sigmoid sinus, and also into jugular foramen. All sinuses we can see in base of the skull except two, except inferior sagittal and straight sinus, sinus rectus. Why impossible to show inferior sagittal and straight sinus here? Because these two sinuses forms only with the help of dura mater. Bones not participate here. All another sinuses between bone and dura mater. That is why we can see them here. In this preparate, what is this sinus? Sinus sphenoparietalis. This is sinus cavernosus, anterior and posterior intercavernosus. Here and here transverse sinus. Another sinus is not clear to see because they below of tentorium cerebellum. And now, we already said about sinuses, and now we continue to speak about meninges. This is arachnoidea. Then here it is a hemisphere, that is brain, right, left and right hemisphere, and here pia mater, yes? And between arachnoidea and pia mater, we have subarachnoid space, and the cerebrospinal fluid is here. And now, arachnoidea, it grows through dura mater. I draw this sinus that is sinus sagittalis superior. Here it is arachnoidea, and arachnoidea grows through this dura mater into the sinus. It grows into the sinus, and cerebrospinal fluid from subarachnoid space, it goes to sinus with the help of these granulations, granulationes arachnoidalis. These granulationes help to conduct cerebrospinal fluid into sinus, and here it mixed with venous blood and leaves skull through internal jugular vein. Clear? That is circulation of cerebrospinal fluid. It forms inside of ventricles. From lateral goes to third, from third into fourth, from fourth into subarachnoid space, and from subarachnoid space, with the help of granulations of arachnoidea, goes to sinuses. And last, blood supply of brain. Necessary to repeat what we decided. Now I will not draw. I think you have. Yes. Anterior cerebral, medial cerebral, posterior communicating, posterior cerebral artery, from arteria basilaris, superior cerebellum, inferior anterior, they are vertebral, inferior posterior cerebellum, arteria pontis, spinalis anterior. And new information, I think it is new information for you, areas of the blood supply, for example, arteria cerebri anterior. This artery, it passes here, yes, and it supplies gyrus, what is this guy?
Gyrus rectus.
Gyrus rectus, together with bulbus and tractus and factorius. The same, it supplies gyrus frontalis
Superior.
upper part of gyrus
Precentral,
precentralis,
postcentralis gyrus,
and lobulus parietalis
superior,
and all medial surface till sulcus
palatino-occipitalis.
All of this part of brain supplied by anterior cerebral artery. Arteria cerebri media, medial cerebral artery, it passes through
Sulcus cerebri
and
lateralis.
supplies all another medial and inferior frontal, lower part of precentral,
Postcentral,
inferior parietal lobule, and
Temporal lobe.
temporal, most part of temporal lobe. And posterior cerebral artery supplies occipital lobe and medial surface till sulcus parieta occipitalis. Yes? If we speak about arteria spinalis, 3 spinal arteries, anterior and 2 posterior, and these spinal arteries passes together with spinal cord in vertebral canal, and they makes anastomosis. For example, in cervical department, we have arteria intervertebralis which join together vertebral and arteria spinalis. In thoracic department, we have arteria intercostalis posterioris, and these posterior intercostal arteries the same makes anastomosis with arteria spinalis. And in lumbar department, arteria lumbalis, yes, it is abdominal aorta, it gives arteria lumbalis, and lumbar arteries also makes anastomosis with arteria spinalis. This anastomosis is the same necessary to know. Area of the blood supply and blood supply of spinal cord with anastomosis.
Okay.
Here questions? No? Well, that is all today.
So diagram.
Diagram, only this diagram necessary to do, only this diagram, all another for you understand.
Oi, mini exam